So we talked about points ignition, and when we got rid of points, we kept the cap rotors, distributors, spark plug wires. We kept all that stuff. We upgraded some of it, but we kept it. The major change is how we got the trigger and how we control the switch. So an induction type pickup assembly are electronic assemblies that use a magnetic pulse sensor to generate an AC signal. And this is one of the type of pickup assemblies we use. We use induction pickup assemblies. I'm going to talk about Hall pickup assemblies, and I'm going to talk about optical pickup assemblies. Those are the three pickup assemblies we use. So this first one is going to have two wires. It generates its own electrical signal. So they come in a variety of configurations, but all of them have a stator, also called a pickup coil, mount on the distributor body, and a rotor unit called a reluctor or trigger wheel attached to the distributor shaft. The reluctor has 1, 2, 3 cylinder and interacts with the stator to trigger the ignition module. The stator may have only one projection with a stationary coil of fine enameled wire around it, or in a circular magnet type number of projections, which we don't really care about. It's information, but it doesn't change how you fix the car. So here is a sample of, here's the distributor pickup coil. Unfortunately, to confuse you, these are all crank sensors or cam sensors. They actually look like it's crank, crank, crank. Yep, those are, they could be cam. But the odds are they're all crank sensors because they're permanent magnet or inductive type. I wish they hadn't put them in the picture. The one here in the center, this goes in the distributor right here. So this is going to have a wheel on the distributor shaft that as it turns, in this case, one pointer. And as it goes around and hits each of these, it's going to fire and tell it, hey, we just triggered. Some of them will have one piece here with lots of pieces going around. So you can design it either way. As we can see here. Here you can see I got 4 things. It's a 4-cylinder, but yet I only have one spot where I'm triggering off of. So I can do it either way. Depends on what this right here is Chrysler right here. So you can do it either way. Here we have the wire going to a module. The module is my switch. This is my trigger. And I'm looking at the signal going to my module, and I get a waveform. So we can test these a couple of different ways. I can test them. This unit right here, or these units here, there's a specification. I can put an ohm meter around it and measure resistance. But just because it has the correct resistance, does that mean it's going to make the correct signal? Absolutely not. Not to mention, what if there's something wrong with my trigger wheel? What if one of these is broken off, or there's too much air gap here, then it won't see it? The sensor would test good, it's just not going to give me the right signal. So I'd always want to use a scope for this, is really the preferred method. If I don't have a scope, I could ohm it out. At least if it was really, really bad, I might be able to figure that out. For example, if their specification is 150 ohms, and I use an ohm meter and it's at 5,000 ohms, I can pretty well guarantee it's bad. But if the specification is 150 ohms and it measures 150 ohms, that doesn't mean it's good. So I can use an ohm meter to prove it's bad, especially if it's way out of range, but not necessarily it's good. So here, my induction type pickup assemblies, a voltage is induced into the winding each time the magnetic field changes. The dwell control section determines how in the duty cycle the primary circuit will be switched. So that's all inside the module, and that's why we say the modules are able to change that on electronic ignition, or we don't have a fixed dwell. And so it can be varied according to engine speed and load. And low inductance coils have low primary winding resistance and number of turns. So I don't need to have the same resistance in the circuit. I'm able to redesign the coil a little bit, make it more efficient, because I'm able to control the saturation here. Ignition advance may be provided by centrifugal and vacuum advance mechanisms in the distributor still, or it may be controlled by inside the module. So early systems up until early 80s It was always just vacuum and centrifugal advance. From early 80s to 1990, 1991, we saw that change where it became computer controlled timing depending on the manufacturer. A switching transistor acts like the relay, just a switch. Primary winding, the coil is continually turned on and off as the reluctor teeth spin past the stator, which isn't that what we do with points? Every time they opened, we fired the coil. Here we're just using a stator and going time to fire, time to fire, time to fire, time to fire. Right, so our trigger is doing that. So instead of having everything built into that little mechanical set of points that cost $5 or $10, we now have a couple $100 module and a $50 to $100 pickup assembly in the distributor. So this lasts a lot longer. It's much more accurate, much more durable, but the initial cost is much more. So Hall effect. Hall effect sensors are another kind of sensor we use. These are all 3-wire sensors. So one way I can tell if I'm working with an inductive pickup or a Hall is how many wires it has. If it only has 2 wires, it's going to be my inductive pickup. If it has 3 wires, it's going to be a Hall or an optical. And a lot of times opticals will have 4 sensors because they're 4 wires because there are actually 2 sensors in one, as I'll show you. So a Hall effect or switch could be located inside the distributor to signal the ignition module when to turn the circuit on and off. Isn't that the same thing we were doing with the inductive pickup? But here's the advantage of a Hall. A Hall will work the same whether it's at very low speed or very high speed. It's going to work with the same accuracy. An inductive pickup at low speed will not generate enough of a signal for the computer to see it, and therefore the ignition will not fire. So Hall sensors are much more accurate all the time. They're much more accurate at speed. They're much more accurate at low speed, and they can measure at low speed where an inductive sensor cannot measure. So we have some significant advantages to a Hall. The disadvantage, I'm running 1 more wire, so it's more cost. I have to supply power to the Hall unit. So I have to send power there where an inductive pickup makes its own power and just sends a signal out. So I need to have another circuit in the PCM or somewhere else to provide power to it. And they're more expensive to manufacture. But Hall effect generators operate using a potential difference or voltage created when a current carrying conductor is exposed to a magnetic field. So Hall effects are really switches. They go on or off. They're digital, where an inductive pickup is analog. And I'll show you what I mean coming up here. The stronger the magnetic field, the higher the voltage. Hall devices are made of a semiconductor material. The integrated circuit contains miniature versions of various electrical components, all within one housing. So if I look at my circuit here, we can see that I have a 12-volt signal. I have a 5 volts here and a signal return. It's interesting they drew it that way, and a ground. That's not quite how they work. That's interesting. Here's my signal return. They're using 5 volts as a bias voltage on the signal return, and we're seeing no voltage here. So they wrote, it's an unusual way to design it. I'm not sure, they must have gotten it from somewhere. I'm not sure who does it that way. And we're feeding 12 volts into the Hall. Most of these systems a lot of these systems only feed 5 volts into the Hall. Some do feed 12, and I'll show you a sample of a 12-volt one. What they have in here is they have this 5 volts never goes through this resistor unless this is unplugged. And then I have a sensor right here. This is my sensor wire right here. So depending on the position of these blades to here is going to change what it sees. And I'll show you that in about 2 slides. So an interrupter ring systematically blocks and exposes the magnetic field. With continuous rotation, the blades repeatedly move in and out of their gap, and the signal voltage turns on and off repeatedly. So a couple advantages here is AI can make a pattern. So I could tell the computer every time we come to number 1 top dead center. I could tell it when we're at number 1, number 3, number 4, and number 2 top dead center. I can do a lot more things with it by varying the pattern. So here is an example of a Hall. This is not in your book. This is some other material I have. And so I can see the magnetic field. So if I can see the magnetic field, my voltage is high. When we block it, the voltage is low. So I can see you, I can't see you. I can see you, I can't see you. So based on how we make the blades, I can control how often we see each other. And so we use these in distributor pickups, which we're talking about. I use them in cam position sensors and crank position sensors. Some manufacturers occasionally will use them for a wheel speed sensor in for the ABS system. It's rare because they're more expensive. They do have some modified hulls that they use for that that are 2-wire, that are special just kind of for ABS stuff. We will use hulls sometimes on transmissions also for sensors. So we can see here at the bottom, here's a pattern, 0 to 5, 0 to 5. So depending on the pattern of the teeth, I can put different patterns into my hull. So now I can make different parts of the pattern mean different things. So with that being said, here, I'm going to show you a picture here. Here's a vehicle that I took off a Ford truck. And this truck was misfiring on one of the cylinders all the time. And the coil was not firing. So it was not firing every seventh time. So it would fire 7 times in a row and then not fire. Fire 7 times in a row and not fire. So I could see the spark tester on it. I could count it 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And so I knew the misfire was being generated on the primary side. And it was not a problem with the spark plug or spark plug wire or something like that. So I'd already excluded that and worked my way back to the coil and tested the spark of the coil and saw that I was only firing 7 out of 8 times. Well, that means the coil has to be good because the coil worked the other 7 times. And it's not working exactly every 8th time that it should fire. Where if it was a bad coil, it would intermittently not work. This is exactly, you could count it. So that means it has to be a primary signal issue. So what's more likely? I got a switch that's bad or a trigger that's bad? Let's think about it. Does the switch care which cylinder I'm on when it switches?
No, it does not.
It does not. So it can't be a switch because it's switching perfectly 7 times in a row and then stopping, 7 times in a row and then stopping. If it was a bad switch or a bad module, it might go 3 times stop, 5 times stop, 1 time stop. It would be random. This is exactly
a trigger problem.
Exactly. So it can't be part of the problem. So the ignition control module or igniter cannot be what's wrong because it's only the switch, which means I need to look at the trigger. This is a picture I got of the trigger. So as we look at this picture, can we see any patterns?
Yes.
What patterns can I see?
Well, you can see that it is switching from 0 to
0 to about 12 and a half, 13 volts, something like that. Okay, so I'm switching up and down.
Right, but some of the patterns are not there.
Okay, so I'm coming along and I'm switching, and
right there, you kind of lose the signal.
Okay, am I losing the signal, or is the signal just shorter? It's less time, right? Because these are pretty wide. This is short. If I made this one wide, it's probably about the same spot, right?
Yeah, it is.
So, but it's definitely skinny, right?
It is.
Okay. And does it happen every 8th time?
Yes.
Okay. What else do we see? How about this guy?
That guy is, the voltage goes low a little.
Yeah, it's shorter, isn't it?
Yeah, it's
right.
shorter.
It doesn't go up as high. And that happens every time too, doesn't it?
It does.
Okay, so one of those is supposed to be there and one of those is not supposed to be there.
Okay.
Understanding what I talked about on a Hall switch, which of those 2 do you think should not be there?
I think that the shorter one shouldn't be there.
You're right. Why shouldn't the shorter one be there? You're right. But why do you think that is?
Because they are all supply the same voltage.
Right. And its Hall is a switch, right?
Right.
Off, on, off, on. This went off. It never went to on. The
Right.
computer, and actually when I read on this, the computer, it has to go over 11 and a half volts for the computer to see on. If
Right.
you look here, 11 and a half volts is right about where the top of my arrow is. We're never getting there. So the computer never saw that turn on. Our narrow one that we saw at first, that's my cylinder number 1. That's my synchronization signal. That's supposed to be there because the computer will always see that because it's tall enough. It just sees it for a shorter period of time saying, oh, number 1 cylinder.
Right. But the voltage is constant.
Exactly. The voltage is where it should be because we're just switching. How long we switch can change. That sends information. We still have to switch the same height. Good job, Umberto. You figured out not only that it was bad, but why it was bad.
Thank you.
But you see how I got there from I'm misfiring on a cylinder. I don't have any spark coming out my spark plug wire. I don't have any spark coming out my distributor cap. Let me check the spark coming in the distributor cap. And then I saw 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So that told me it wasn't a cap and rotor problem. It was a problem coming in. As soon as I saw that, it can't be the switch. The switch works the same every time. It doesn't care which cylinder it is. It has to be a trigger problem. And once I get to the point it has to be a trigger problem, now I got to put a scope on the trigger. Let's look at it because it could have been a bad sensor. It could have been a bad ear on it, which is what this one was, right? Because if it was just if it was a single sensor with 8 ears, it'd have to be the ear because the sensor is the same. It's depending on the ear that goes by on the star wheel. On the other hand, if it was like the one we saw where it has different stars going all the way around, then it would be the sensor itself. So for me, I cheated. I put a whole new distributor in it, fixed.
Beautiful.
So because once I got to it's a distributor, that distributor had 200,000 miles on it. Do I really want to, and I have the special tools to take it apart, but do I want to take it apart, put that in, put that 200,000 mile distributor back in, or just get a rebuilt one for probably less money to the customer or the same money?
Yeah,
And it's going to be a better repair because it'll all be new. It'll have the bushings will be new. It'll all be serviced. And so that made the most sense to do. It was a better value for the customer, even though I have the tools to rebuild it, because in the past we couldn't get tools to rebuild them. We had to rebuild them ourselves. And if you don't have the special tool, you break the gear on the bottom of the distributor.
Oh yeah, easily.
So, and there's a special puller for these Ford distributors to do that. So that is what we did. So we got the picture here, and I put the, I got some good information in here on on what I found and why. So I got some good instructor notes in here on the PowerPoint for this, because this is stuff I added. So a lot of times the stuff I add, I try to put some notes in there with it, because the other stuff is kind of copies of what's in the book. You got the book to kind of help you with that. I try to put in the other. So Hall signal. Look at the scope pattern on the previous page. Is the sensor operating correctly or not? If not, what's wrong with the pattern? And I kind of talked about this while we were looking at the pattern. So this should be pretty much a gimme. But it's still reinforcing what I talked about, so I left it in. Okay. So a Hall effect requires how many wires in order to operate? And this is important because if I can look at a sensor and see how many wires it has and have a good idea of what kind of sensor it is and how it has to operate, I instantly know how to test it. 3-wire sensors, whether it's a Hall we're talking about here or an optical sensor we're talking next, I can test them the same way. A permanent magnet I need to test differently. So I know what to expect based on the number of wires and how the sensor works. And we're going to get into a little bit more into sensors in the next couple of weeks and talk about that. But it's really important to, because we're going to see things we've never seen before. But by understanding some basic rules as far as how many wires and based on how many wires, what kind of signal should I probably get, really helps me learn what I should look for if it's not working, even before I go get the manual. It also lets me understand what the manual is showing me. So I like to spend a lot of time on just kind of this quick visual ID. What am I actually looking at? So optical sensors. The only ones I know for sure that use the optical sensor is Nissan. They use 2 sensors in one here. So that's why we got 4 wires going to it, as you'll see. We actually have 2 separate sensors. They each share the same power and ground. They use a light emitting diode and a phototransistor located inside the distributor and can be used to sense position of the crankshaft. The rotor plate is attached to the distributor. A typical rotor plate has 360 different slits in it at 1 degree intervals on the outer edge. So again, pretty doggone accurate. I can see every degree. It works similar to a Hall in that it's either on or off, right? Either I can see the light or I can't see the light. So that we really have not had a lot of issues with these. We thought we were going to when they first came out, would have been late 80s. This was really cutting edge. The 300Z, when it first came out in 86, I think it was, had this. So this was really cutting edge technology in mid 80s. We really thought it'd take off. No one other than Nissan has really used it, and they used it in their distributors all the way up to 03 when they stopped using distributors. So here's our sensor right here. And we can see I have a big hole, which tells it which cylinder it's in. Again, by changing the size of the hole, it can decide, it can figure out, oh, I'm on cylinder 1 or I'm on cylinder 6, right? How many degrees, because I got the little slots, how many degrees is the big slot? So if I make one big slot 2 degrees wide, another big slot 5 degrees wide, would it be real easy to tell the difference between the two with that distributor going around? So, and so there's actually 2 sensors in here, one, and they're staggered. So one's looking at the 360, the other one is looking at the cylinders. The only issue we had with these is if we got water in there and you got corrosion, you'd actually get corrosion. It would make the single degrees get too small and cause some weird issues. That was rare, but I've seen it happen. The other issue is just the sensor itself goes bad, and I've seen a few of those go bad also. But again, not a high failure item. Crank angle position, control unit determines ignition time and it switches the primary circuit on and off by controlling the operation of the power transistor and the control module. So again, just another form of trigger, except for here we got the single degrees and when's the cylinder happening. So I can do a lot more control for ignition timing. I really have a nice system. In an electronic distributor ignition system, what component is the switch that fires the coil? Okay. So we look here at my secondary ignition on my electronic ignition. We can see here my secondary ignition is coming out of the coil into this distributor, down to the distributor rotor, over to the end of the distributor. It jumps a small gap there. It's called my rotor gap. And then the spark comes through the spark plug wire, through the spark plug, and jumps to ground. So I showed you a picture earlier. This was 2 slides I had. one showing the primary side of the system. Here we can see our trigger here. My pickup or field coil sends the signal to my module. My module switches the coil. And then after my module switches the coil, it comes out through my secondary, through my rotor. This is actually touching in the center. It comes out to the edge of the rotor where it is not touching. It jumps the gap from the rotor to the distributor cap, through the spark plug wire, down to the outside end of the spark plug, and then jumps. Oh, speaking of spark plugs, Leroy sent me a message that the spark plug article didn't open properly. I did get that fixed, and thank you, Leroy, for letting me know that that was one of the lower permissions didn't get toggled right when I moved it over. So thank you for bringing that to my attention. I got that up and running. So high voltage is sent to the spark plug through the wires, the coil. So here is a complete electronic system. Here's another one, a little more where we can see I got the ignition switch in here. I've got the ignition module in here. And I've got, so there's my trigger, which is in the distributor. There's my switching device right there, which is my ignition control module. So even though these systems look slightly different, they have the same main components. I got to have a trigger. I got to have a switch. I got to have a coil. I got to have spark plugs. I got to have a wire that connects the coil to the spark plug. So as we look at new and ingenious ways of building cars, when I have a car that doesn't run, what I need to do is back up and go, what is this guy's job? Is he a switch? Is he a trigger? What is the job of this component? Or maybe I should say, is she a switch? Is she a trigger? Whatever. But it's, you get the idea. So what is the purpose of the distributor pickup in the ignition system? Okay. So distributorless or waste spark ignition. I think the book goes right into calling it waste spark. It was really known as distributorless ignition. Waste spark was kind of GM's name for it that really took over. This is a GM system right here. This is not in your book. This is one of my slides. So let's find the same components that we have done in previous systems. So let's look for our coils here. So take a second, see if you can see where the coils are. And we actually have 3 of them right there. So we have 3 separate coils here. So where's the trigger? Kind of look at the schematic, see if you can figure out where the trigger is. And there's my trigger. And let's take a look and see if we can find the ignition control module. Which is what? My switch, right?
Yes. Left side. The ignition system module.
And there's my ignition control module. How about my powertrain control module or engine control module? Can we find that?
On the upper on the left.
Yeah. And there's my ECM right there. So as you can see, these systems all require these parts. The trick is knowing where to find them. And how did you guys do finding some of those things? I have a feeling some people did better than others, and that's fine. That's why I put this PowerPoint slide in here.
So
I think
this is for a new car, and the other was for like,
this is from probably 1980,
okay.
definitely 88. I think 87 had this system or variation of it. So this is 1980s, and we still use this system on some cars today. This happens to be GM 6-cylinder. This is off of Buick, I think.
Okay.
But we still use this system on some cars today. Not
Like
very often, but some of them still use it.
Like-
But it's relevant because there's a lot of these cars out there. We have some of these cars at the college with this system. And the other thing about this system is that it's really just about finding the components. Did I find the coils? Whose job is it to trigger it? Hey, that's the trigger. I can see that. Okay, so the ICM is the switch. So if my coils aren't working, am I getting power and ground to the module? Is the module of the ICM getting a trigger signal? If it's getting power and ground, it's getting a trigger signal, and it's not switching the coils, guess what? It has to be bad. So instead of guessing at these parts that can get really expensive, let's step back and ask a couple questions. What is its job? And who's it supposed to share that job with or tell that to? Is it doing its job? You know, is it seeing what it's supposed to see and not sending it out? Is it seeing what it's supposed to see and sending it out? Or is it not even seeing what it's supposed to see to work? And that's the beauty of a scope, is because you can get in there and see that much quicker. But from a logic standpoint, you saw on that Ford, I was able to figure out which part was bad by simply just using a spark tester and narrowing it down and figuring it out. Then I knew in my mind where the problem was. I just used the scope to prove it. I already knew where it had to be. I already fixed it up here before I ever put the scope on the car. I didn't know why it wasn't working. That was kind of cool about putting the scope on. I wanted to see the why, but I already knew that's what it had to be. I already had the part ordered before I even scoped it. I just wanted to scope it because I wanted the capture and the case study, everything else, because it was kind of a cool deal, and I published that case study. But I already fixed it up here.
Okay.
Just by process of elimination and asking the questions we just did on this slide. What's this guy's job? What's this guy's job? What should he do? And that's why I always say it's really important to try to fix things up here. So distributor ignition components. Distributors eliminated and replaced by multiple ignition coils. Mechanical parts include a distributor assembly such as bushings, bearings, breaker plate assembly, advanced mechanisms are all eliminated. Two main types of distributor ignitions, waste spark and coil on plug. Neither one of those use a distributor. In a waste spark system, there is one ignition coil for every 2 cylinders. And they're companion cylinders. So remember we talked about if I have a firing order of 1, 3, 4, 2, cylinders 1 and 4, pistons are at top dead center at the same time. So what I'm going to do is I'm going to fire the spark plug on both those cylinders when that piston's close to top dead center. One at the top of the compression stroke, the other at the top of the exhaust stroke. And what I'm going to do by doing that is any leftover hydrocarbons that are in that mixture on the exhaust stroke, I'm going to hopefully atomize. And that's why they call it a waste spark. The other advantage of that, if I back up a slide, if you notice, I only have a crank sensor here. There's no cam sensor. How do I know which cylinder is at top dead center compression? Cylinder 1 or cylinder 4? I don't. It doesn't matter. I'm firing the spark plug on both of them at the same time. So it doesn't matter which one's 1 and which one's 4 at top dead center compression. So you see how I could actually get a car to start faster because I don't need to wait to see which one's at top dead center. All I got to do is know I need to fire cylinders 2 and 5, 2 and 3 or 1 and 4. So boom, I can start the car a lot quicker. would that reduce the number of emissions I put in the air when I'm starting the car? I'm seeing
Yeah.
some dead bobs. Yeah, because as I'm cranking the car, we're spraying fuel into the car. So the longer it takes me to start, the more unburned fuel I'm dumping in the atmosphere, causing smog. So manufacturers really want that car to start as quickly as they can. So this system, which is really very advanced for the time, but very simple in retrospect, was able to do this off of just one sensor, the crank sensor. They didn't need a cam sensor. So they did this originally on Buick, and they used it in other things in the system. So waste spark system, one ignition coil for two pair of panties. So here is, and I wish they hadn't put the coil on plug-in with this picture, but they did. The one on the left, the A, is a waste spark ignition coil. So it has two terminals. That means that one of those terminals each goes to a spark plug. Each has a spark plug wire. The one on the right side, the B, is a coil on plug coil. That's where the engine has a separate coil for each cylinder. Signals from the crankshaft position sensor, and if equipped, the camshaft position sensor, are used by the PCM to control on and off signals to the primary windings of the coils. If it is a coil on plug system, it has to have a cam sensor. It can't run without it. Both sensors are Hall effect or direct type sensors. Not necessarily. We still have cars today that use induction type. Oh, they just say or induction type. I'm sorry, I misread. So here is a coil for a distributorless ignition system. This is waste spark. So I have how many coils here?
6,
No.
5.
4, and 3. Yeah.
3.
3. Remember, it's waste spark, so each coil fires 2 cylinders. So there's 3 coils in here. And if you look closely, you can see how the companions are done on the coils, where I got cylinders 4 and 3, 6 and 2, and 5 and 1. Because on this engine, cylinders 5 and 1 are at top dead center at the same time. They're the companion cylinders. If we look down here, how many wires go here?
8.
4. 1, 2, 3, 4. I got 4 spades. So what I have is I have 1 power wire, and I have 3 negative side coil wires that go to my module, which is where my switch is. So this looks complicated. It's simple. I have 3 2-wire coils, and they're all sharing the same power wire. So electrically, this is a simple system. Very confusing because what? It's in a magic box. I don't know what it does, so I'm going to guess it's bad. I can test this coil the same way I test a coil on a 1955 Chevy. There's no difference. I just happen to have 3 of them in one box. Okay. Don't let this stuff intimidate you. I know that we've got a lot of technology. I know there's a lot of stuff, and that's why I always try to drill down to what is its basic function? What are they really doing? Let's not get intimidated by it's shiny and new. Let's look at what it actually does. Another thing on these, because they fire both the, in this case, cylinder 1 and 5 at the same time, we actually fire 1 from positive to negative and 1 from negative to positive. So we actually make a complete circle, a complete loop. And so we can actually go through and figure out which one of these are positive and which one of these are negative. So the firing order, shoot, it's below my thing. Doggone it. Let me, because I want you guys to see this. Let me stop this for a second and swap this. Let's go to stop share. Come on. There you go. So there's my firing order. The firing order on this engine is 142536. And so if you look at that, that makes sense because 1 and 5 are companions. 4 and 3 are companions, and 2 and 6 are companions. And we can see that on the sticker where it shows where they go together. So now if I want to figure out who's positive and who's negative, I would take the firing order and I would start with a plus, and I would go plus, minus, plus, minus, plus, minus. And that tells me who has positive and who has negative. And why that's important is if I put a scope on this, if on the negative, my whole pattern will be upside down. It'll show negative voltage. So here's my positive, negative, positive, negative. So let's see here. I got cylinder 1 is positive, cylinder 4, negative, cylinder 2, positive, cylinder 5, negative, cylinder 3, positive, cylinder 6, negative.
From here come like high voltage.
What's that?
From here, what come out? High voltage.
High voltage. But
And
one,
you can
but on the positive side, it comes from the coil to the engine. On the negative side, it comes from the engine to the coil. And I got a picture coming up that'll show this a little bit. So cam and crank sensors are used in distributed ignition systems to calculate engine speed and determine engine position. Crankshaft position sensor functions like a pulse generator in the distributor. The two sensors work together to control firing of the spark plugs and control variable valve timing. Also used for fuel injection control, the concentric interrupter rings inside the engine for the triggers off of. Come on, where's my... Yeah, I'll keep that. All right. So here's a picture. We're talking about the interrupter ring on a crankshaft pulley. So sometimes we put the ring on the crankshaft pulley and the sensor may mount to the front of it, such as they're using here. GM did this. We actually have two with this example. They're not telling you, actually has 2 crank sensors built into it. It's a 3 times and an 18 times crank sensor. So there's actually two different sensors built in here. And then they're showing a cam sensor at the top. So I'd actually see a total of 3 sensors on this car. I can use these sensors like we discussed in engine module to actually compare camshaft and crankshaft timing. So in this case, I'm getting a nice square wave signal, which means it's a Hall effect sensor. And I'm able to see the comparison in timing between the two, or if the signal's put out good. So these should always be tested with a scope.
the scope application like transform the life of a mechanic really easy today, because I think 20 years ago, for find a problem like this, you spend 10 hours.
Yes. And people still do. Not everybody uses a scope.
Right.
Okay.
That is like the advantage for a person who, about the technology, like you have to follow otherwise.
Right.
In all field, you know what I mean? You have to follow technology.
Yeah. And I think that technology is really important. And I think it's important to prepare you guys with that technology, not teach you how guys that are already obsolete in industry fix cars by guessing or plugging in or ohming things out or using antiquated tools. Let's look at how the guys that are actually successful and the guys that are at the top of the industry are fixing it. Let's learn from those guys, not the guys that are not successful, right? I'd always rather learn from someone who's successful. So each ignition coil serves the 2 cylinders. Each end of the secondary winding is attached by a high tension lead to the spark plug. A waste spark system fires the 2 spark plugs at the same time, and the event cylinder and the waste cylinder. So event cylinder is another way of saying it's on the compression stroke. The cylinder on the compression stroke is said to be the event cylinder. The cylinder on the exhaust stroke is the waste cylinder. A spark in the event cylinder drives the piston down on the power stroke, while the spark in the waste cylinder simply serves to complete the circuit and possibly ionize any hydrocarbons that are there. These systems put out a tremendous amount of voltage, minimum of 60,000 volts potential. And so here's a nice picture where it shows the arrows. So you can see the current flow. We have a coil pack here. We can see cylinders 2 and 3 are both at top dead center. I'm firing the spark out of the coil into cylinder 2. It's making the ground connection to cylinder 3. The spark's coming back up through cylinder 3 and back up into the coil. Kind of crazy, huh? But think about it. Doesn't a series circuit have to make a complete circle? So in this system, instead of coming out of the coil into the battery, we're coming out of the coil and back to the coil. That's our loop. When the crankshaft rotates through 1 revolution, the rolls of the cylinders are reversed. Timing is controlled by the PCM based on all the engine sensor data. 6-cylinder engine has 3 coils, and the coils can be combined into 1 coil pack, or they can be separate coils.
I'm sorry. Here with 1 spark, fire 2-cylinder with reverse.
What A here is? You're talking about A here, Mario?
No, go back. It's like the sparks 2-cylinder with 1.
Yeah,
Spark.
sparks 2 cylinders with 1
To
coil.
do like positive to negative, negative to positive.
Exactly. So it starts here, it goes through here, back over to here, and back
It's
into here.
totally different design compared
Yep.
to the.
And there's probably, I haven't looked, but I would assume there's some good animations on this in the CDX media library that you might want to look at.
It's good to know that exists like a system like that.
It is, because if you put an ignition scope on it and you're on the negative one, your ignition pattern, instead of going up to 100 volts, comes down to 100 volts.
You go crazy if you don't know.
And you go crazy.
Thank you.
You bet. And here's a slide I put in. It shows the positive to negative. And
Transformer.
right, you can see the priority. Here's a coil.
Yes.
Here's my trigger, and it's moving through the system. So I put this one in here. This is kind of a complicated concept, so I try to give it to you like on 5 different slides. It's all saying the same thing.
Luckily, a step-up transformer. Luckily, I'm confident with this.
Yeah, so here's another one right here, PCM, battery positive. Here's a coil. We're at my flow direction. We're coming out through here. We're jumping on the ground, coming this way. Now we're jumping the other way across the spark plug and back up to the coil.